Hello everyone, I'm Mike Smith, and alongside my friend and colleague, David McCurrach, we'd like to introduce to you the use of virtual reality in task-based language instruction. Before we begin, however, we'd like to thank you, the attendees, for subjecting yourselves to this presentation, and also to the organisers of ACIE 2022 for putting this conference together in such a professional manner in these trying and uncertain times. Why virtual reality? Well, we believe that VR can improve language education by providing students with memorable and immersive experiences that would otherwise not be possible in regular classroom environments. Additionally, VR is an extension of computer-assisted or computer-aided language learning, otherwise known as CAL, which shares several theoretical and practical elements with task-based language learning. This includes learners actively exploiting schemata to achieve learner-specific communicative requirements, establishing internal syllabi to navigate specific language generation contexts, and finally, participating in tasks applicable to authentic or relevant communicative requirements.
Thank you, Michael. Hi, I'm David, and I want to discuss what we mean by VR. So, to do that, I'm going to talk about virtual worlds, environmental interactions, what I mean by visual and tactile feedback, and having a high sense of immersion. So the first thing I want to talk about is collaboration. Because VR can be networked, it can actually increase peer-to-peer and student-to-content interactions. We'll talk a little bit why later, but it's this sense of connecting people, essentially. And because of this is shown to improve self-reflection and increase motivation to participate. This also follows on to reducing anxiety in these kind of peer-supported environments. So although you might think of it as isolating, VR can actually help people connect more easily. So the next thing I want to talk about is perhaps in direct contrast to collaboration, and that's learner autonomy. This language is often used synonymously with computer-aided language learning because it's about giving agency to the learner. But it's different and arguably better in VR because when you're in a VR space, you're essentially negotiating meaning when you interact with the environment, which creates kind of stronger connections during the learning process. And similarly, as with other cool applications, you can be in these kind of highly learner-centered environments that kind of might target the weak points of the individual learner. And because of this, a higher sense of self-efficacy can be made. And there has been studies showing that learners prefer this over the traditional classroom. Since language learning can be learned implicitly or explicitly, and because VR is a multimodal platform, this can really increase the rate of learning. What do I mean by multimodal? That means there's the visual, the auditory, tactile, so the feeling, the sensations. So put them together and it really increases and strengthens how we learn more quickly and easily. So you can kind of think of for example, like a virtual kitchen environment where perhaps learners can learn and see food, they can make food, they can use utensils, listen to instructions and have the vocabulary labelled or spoken upon using them. And so what this does, it creates a causal relationship which Hansen and Shelton call cognitive restructurings during this circumstantial learning. So it's a very effective and maybe even efficient way of learning a language. The last defining feature of VR is something called presence, and it's something that really distinguishes VR from other forms of immersive educational technology. The best way to describe presence is a sensation of being there, or the feeling that your mind has been transported somewhere else due to this multimodal nature of the technology. Basically, you feel like you're somewhere else, and in terms of learning processes, you're essentially tricking your brain, and as it responds to stimuli, it's reacting despite knowing the contrary. and this gives direct benefits to language learners. There's been studies showing that the heightened effect of presence has increased the accuracy of test answers. And another study showed that lexical recall of verbs also increased depending on how realistic the environment felt.
I'm going to put it on you first. Welcome to virtual reality.
What's it like, Ron?
Oh, it's mental.
So those are the controls right
Wow.
What are you going for, the 6? Oh, mate.
That has freaked me right
Only you
out.
could lean on a virtual reality table.
Can I take these off? That is weird.
Okay, so that's the theory out of the way. But what of the actual learning experience itself and the strategies we suggest for task-based language instruction? When it comes to physical hardware, we recommend the Oculus Quest, which is a self-contained VR gaming headset which, unlike previous iterations of the product line, does not require any physical or digital connection to a PC. Consequently, it's much easier to set up and, more importantly, use. Due to the self-contained nature of the Quest, there are no cables that restrict movement, which may potentially break immersion. Additionally, the Quest is powered by Oculus Insight, an incredibly accurate, real-time tracking system that computes user actions to the nearest millisecond. This includes tracking the user's headset position and constellation tracking to monitor controller positions, regardless of real-world location or play area boundaries. Regarding physical input, meanwhile, player actions are recorded using a pair of Oculus Touch controllers, which, among other actions, allow the user to pick up, hold, and relinquish objects with realistic precision through haptic or tactile technology. With regards to software, meanwhile, there exists a myriad of potential applications that may be used during task-based learning, several of which we will cover later. But, in order to provide a highly collaborative experience, we recommend employing the Oculus Rift hardware in conjunction with the information gap puzzle game Keep Talking and Nobody Explodes, which several of you may already be familiar with. While this game is not designed specifically for VR, it does require a high degree of collaboration and information exchange in order to solve each puzzle. Thus, the game provides a perfect environment for enhancing communicative competence and problem solving. Information gap activities are perfectly suited to communicative language teaching, which is itself the forebearer of task-based language learning. Keep Talking and Nobody Explodes is available on the majority of gaming platforms, from consoles to PC and even smartphones. But we argue that VR provides the optimum means of experiencing the game, especially within a pedagogical context. Specifically, the software is designed to be played with at least 2 participants, with the player operating the VR headset tasked with disarming a procedurally generated explosive device. Each puzzle is procedural in the sense that it spawns into the game using a combination of components, which are taken from a potential pool of 11, including keypads, Simon Says, Morse code, Y sequence, and password activities. Consequently, the player solving the puzzle is labelled the diffuser. Here, the diffuser is assisted by at least one partner expert, who communicates the information necessary to successful completion. This information is contained within a bomb defusal manual, a contextually immersive instruction booklet or guide. This is the essence of the information gap activity. Crucially, the specific modules of each device manifest algorithmically, or through math-based computational procedures, resulting in a near infinite pool of puzzle combinations, and the requirement for participants to generate linguistic and problem-solving strategies in real time through the rapid and accurate exchange of information. Accordingly, Keep Talking and Nobody Explodes serves to enhance the following holistic skills. 1. Functioning efficiently and strategically as part of a team. 2. Describing, labeling, and communicating visual information. 3. Generating questions to elicit feedback. And 4. Searching specialized EFL text to locate precise instructions. By way of example, here's a short clip showing what not to do in Keep Talking and Nobody Explodes.
I don't know how to say it.
You explain it to me and then I understand it.
Which one are we at? Which column are we
What
at?
thing is this?
I'll guess this one.
Okay.
I have double 2 X's. I think I guessed wrong. I'm not sure.
I think you
That's
guessed
the only
right.
two things
Is
I
there
have.
the
I get
double K?
lost.
Star, K, or A? Which one is the next one?
Oh, A.
Yeah?
Oh.
And then K and then star.
You died?
Yeah.
Let's start with the wires.
There's super dark room. Hello. The time is ticking. Come on.
It's okay. I think you have to cut the last one.
Given the noted complexity of Keep Talking and Nobody Explodes, it is absolutely vital that learners are given adequate time to prepare. Prior to task implementation, each learner should be sufficiently warmed up, thoroughly briefed on the activity at hand, provided with appropriate task orientation activities. In this case, we advise providing learners with a list of simple, task-specific vocabulary with translations and examples of how to use said vocabulary in-game. Ideally, learners would be aware of all required terminology prior to the session, so we suggest scaffolding your syllabi accordingly, perhaps by introducing this content in the preceding session or as a homework task that may be reviewed at the beginning of class. Other task orientation documents include the module identification chart, which labels each possible in-game activity, and the diffusal manual itself. Once learners have all documents in hand, we recommend allowing for at least 10 minutes of acclimatization, and double that again if the instructor introduces a worksheet in order to strengthen comprehension. As an aside, we also suggest that individual teachers decode the manual, as it were, perhaps by providing translations in the native language of the users, or providing a custom manual featuring simplified terminology depending on the respective foreign language proficiency of the group. In our own practice, we implemented this task using learners categorized as B1 and B2 on the Cepha scale, and they had no problem using the original text. During the period allocated to learner orientation, it is good practice for instructors to prepare a real-time demonstration of the activity, to be introduced once students had finished preparation. Post-demonstration, learners are given the final task preparation activity, the Keypad Identification worksheet. This is crucial as it allows learners to translate and label the 27 abstract symbols used during the keypad task. This handout not only facilitates efficient in-game communication of task-critical visual components, but allows learners to generate unique and memorable lexical strategies for task completion. In doing so, this activity conforms to the previously described concepts of supportive performance and focus on form, in which orientation tasks provide learners opportunities to optimize their task performance by being provided with time to plan and draw attention to forms that are difficult to acquire incidentally during task performance. During the final phase of task preparation, each participant completes the 5-minute tutorial level, which consists of basic orientation tasks such as navigating the virtual space and fundamental task completion measures, including item manipulation, wire cutting, and button pressing. Once all learners are sufficiently orientated towards the task, it's time for the main activity itself, an example of which may be seen here. As we're sure you'll understand, it wouldn't be appropriate to show you video footage of our learners participating in the activity, nor would it necessarily demonstrate the full impact of VR on the experience given the lack of in-game footage. To that end, we've provided this short demonstration video in which former Army airborne demolition experts complete a 3-stage device. It should be noted that, in addition to their professional history, this was their 3rd attempt at the task.
Serial number Alpha 34, Sierra Zulu 2.
Roger, first module.
Got the flat top 6,
Yep.
the trident, looks like a puzzle piece.
Hold on one second. Flat top 6, trident.
The puzzle piece.
Got it.
And a backwards N with a U
Roger.
on above.
Flattened 6.
Flattened 6.
Puzzle piece.
Puzzle piece.
Trident.
Trident.
Weird H.
Oh, we got the maze. The one green dot is top row, 2nd column.
Hold on, top row. Okay, top row, 2nd column. Got it. And the other one is directly below it.
Yep, directly below it, all the way at the bottom. I am 3rd up from the bottom on the far left. And the goal is...
Third from the bottom on the far left?
Yeah, that's me.
Okay.
And then the triangle is 1 up from the bottom, 4th row in.
4th row from the left?
4th column in from the left, yeah.
Okay, down.
Down.
Down again.
Down.
Right.
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 Up.
Up.
Left.
Good to go.
Boom.
Oh, Simon Says. Oh, you
All right.
scurvy shyster.
All right.
Got red flashing.
Okay, hold on. Our serial number contains a vowel.
Yes, it does. There's an A, I believe, in
there's an A
there.
Okay. The red button's flashing, correct?
Red button flashing.
Hit blue.
Blue. Now it goes red, blue.
Okay, then go blue, red.
Blue, red. Okay. Red, blue, blue.
Go blue, red, red.
Blue, red, red. Oh, we nailed it.
Upon eliciting post-activity feedback, we found 3 common themes amongst learner responses. 1. Enhanced enjoyment resulting in incidental linguistic performance. In this sense, task-based interactions involve curiosity-driven engagement, which can impact emotional engagement and one's desire to complete the task. Participants reported a high degree of satisfaction with the task, stating that it was fun on numerous occasions, and that the collaborative and immersive nature of the activity heightened their willingness to communicate, while also serving to create a sense of shared belonging. Theme 2, meanwhile, is a heightened sense of immersion or presence. For example, one learner described how they had to explain things more clearly and listen more carefully because the faces of their partners were not readily visible. The impact of cognitive presence was confirmed by all learners, who agreed that the experience felt much better because they felt like they were transported to the virtual environment. Finally, Theme 3, the applicability of the task to learner context. In other words, authenticity. Now, it should be noted that the likelihood of any of our learners participating in legitimate bomb disposal is remote. However, when we talk about authenticity, we refer to the successful navigation of the task necessitating the use of true-to-life skills, including not only oral communication in English, but critical thinking, problem-solving, peer-to-peer negotiation, and English medium reading, writing, and listening. In essence, holistic skills that may be transferred to other learning domains.
So now I'm going to talk about some of the limitations and a few suggestions for future practice. Although compared to other headsets, the Oculus Quest and now the Oculus Quest 2 are reasonably cheap, class-wide implementation is going to be pretty expensive. There will be some setup and training required for both the teachers and learners, unless they're familiar already. A problem more specific to Keep Talking Nobody Explodes is that it lacks a key presence multiplier, which is basically standing up and moving, because this has been shown to heighten immersion. So just sitting down is less immersive than standing up and moving around, but it's within the constraints of the software. Comfort can also be an issue. The Oculus Quest is still a little bit heavy. You can't really wear it for a long time before it starts becoming a little bit painful. And this is especially the case with people who wear glasses. And because of the nature of the head strap, it can mess up hair, and due to the foam padding on the front, it can mess up makeup. And lastly, another big kind of minus is that there's still motion sickness. Although it's not so bad with sitting down experiences.
In addition to these suggestions, we'd also like to quickly showcase some alternative VR applications that may prove useful in your future practice. To begin with is Star Trek Bridge Crew. Like Keep Talking and Nobody Explodes, this game requires communication and collaboration. Next is Job Simulator. This game places the learner in a variety of exaggerated work-based situations. This may prove useful to study abroad preparation. Finally is Google Earth VR. This application may be used to transport students to almost anywhere globally. This allows teachers to set specific missions. For instance, learners exploring a city before reporting what they experienced in a short presentation or discussion group. Virtual reality education like all forms of CAL or innovative pedagogy in general, takes time, effort, and a not insignificant amount of planning. Planning that must be structured and scaffolded in accordance with the specific needs of our learners. Through showcasing Keep Talking and Nobody Explodes in VR, we hope to draw attention to an activity that at first glance may appear superfluous, yet, as has been demonstrated here, is conducive to honing holistic, transferable skills in a fun and engaging manner. The relative expense involved means that VR isn't accessible to everyone. Additionally, one limitation that we failed to mention earlier is Facebook's ownership of Oculus. At a time when many of us are abandoning the platform, we understand if some of you are skeptical about maintaining a profile with the company just to use VR. There are several alternatives out there, each of which have their own strengths and weaknesses. We suggest considering headsets designed by HTC, Sony, and Valve. Finally, you may find a recent study of ours covering this activity here, alongside a number of other sources cited in this presentation. If you would like to read this study alongside others like it, have questions about VR, or simply wish to network, then please feel free to contact us on ResearchGate, which can be accessed by scanning the following QR codes. In the spirit of taking things with us beyond this conference, the web-based video platform used to create this presentation is RenderForest. This is a website that I have used in my pedagogy, specifically as a means of giving learners a rest from a seemingly constant barrage of presentations. Thank you for your time.